And then to toggle Grasshopper and Rhino, Grasshopper is a plugin for Rhinoceros. So it's got to run through the Rhino environment. It can't be run on its own. And it's queued up through the command line. So I type in Grasshopper into the command line, and it should bring up this window saying it's loading. Now, if it doesn't load, it's going to give you an error saying that you don't have the latest updated version. In that case, you'll need to dig through the internet to find an older version that works with your version of Rhino. Mine's a legal copy, and so I'm always updated, and so always Grasshopper works. If you're doing something that you don't have a license key anymore, or whatever it may be, or you can't update it, you'll need to manage that process on your own. It comes up. How I like to work with Grasshopper is it's a separate, almost program-looking entity. So what I like to do is I like to just drag it over to the right-hand side if you're in Windows 7, and then do the same thing with my Rhino screen. So then I'm working side by side with it, and then I'm working in 3D. So I don't see anything in the Rhino window. Now, we know I can explicitly model in Rhino, but what I want to start developing is parametric models. And so how this works is in Grasshopper, I have what we call a canvas. And I'm just going to go ahead and do File, New, so it gets rid of those documents. So this is my canvas. Really, it's just a board. It's not really drawing or anything. It's a visual scripting environment. So when I make a command for a box, say, so I type in box in Rhino, I see that it's asking me for a first corner, and I click one, and then it's asking me for a second corner, its base plane or length, and then its height. So that operation can be scripted, so that way at any time I can adjust the length, height, and width on that object. It's not explicit, whereas now I have this object, I have to go and do multiple operations to scale it or whatever to change its size. Instead, I want to approach the box as this dynamic piece. So what I can do is, and as we go, we'll learn more about the interface. I'm just going to dive right into it. So when I want to find a command, right? So I want a command of box. We're going to build a parametric box. I just double click on the canvas, and it opens up a search. So I'm going to search for box. And I see I have multiple box commands that I can use. For us, we just want to make a simple box, which is a box 2-point. And this brings up a little component. So we call these components. This is essentially that box command in Rhino encapsulated into this visual entity. Now, if I right-click it on the center band that's darker than the other ones, and I go to the help, so each component has its own set of help files. It tells me that there's an input parameter and then an output parameter. Now that corresponds with left side and right side. So you can see everything on every component on the left is an input. And you'll know it's an input because I have this little half circle. And that half circle is waiting for inputs from other components. So if I right click again, and then everything on the right side's the output. So after I do my inputs, it's going to output something, which is going to be our box. So if I right click again and I go help, I say, what are you looking for? And it's looking for a point, and a base plane. The base plane's given, it's XYZ. We'll be on the XY plane, and we'll talk more about planes later. But I want to begin defining a point. So I have my first corner and second corner. So to define a point with this entity, or this object, I want to begin thinking about it. So those points, I'm going to push and pull them to make the box stretch whenever I want. So to define a point, I can come in and I type construct, because I want to construct a point based on number values. And I can see this word construct point. And then I look at its help file and I say, what are you looking for? So on its input side, it's looking for an X coordinate, a Y coordinate, and a Z coordinate. And basically that's going to go back to your geometry, right? If I defined a point on a graph, it's 0, 0, 0, or 0, 12, 12. Right? So we need to input that data. And I want it to be flexible. So the last part of this construction set is I'm going to do a number set. So if I double click again on the search and I type number, I get a number slider. So this number slider is you know that it's a definitive input segment because it has nothing else that can be input into it. So it's definitely a constructor. It's going to begin constructing geometry for us. Now you can see that it comes in decimal form, and I can change that. If I right click on it and I click on edit, I can see that I'm available with real numbers, which are decimal numbers. I can have integers, which are just whole numbers, and I can have only evens and only odds. So that's what you're basically left with. For this, I'm going to just do normal integers. We'll get into other ones as we get into rotations and things like that. And then I have minimum and maximum. So that's going to be how far do I want my slider to go in the negative direction and how far in the positive direction. And I click OK. So now I have my number slider. And if I want to resize that, I can stretch it. And when I drag it, you can see those numbers now change. So the first thing is to connect pieces. So I'm going to bring that there, bring that down. When I connect that to the x coordinate, I now see a point out in space because it assumes by default, if it doesn't have a number, that it is a 0, right? So I'm just going to Control C and Control V with that number slider, and it gives me another one. And I can hook that to the Y, and I can hook this to the Z. Now if I want to change this, I can double click in it and just tell it it's 0. Hit enter. And now I should have a point at 0, 0. So now if I want to change where this point goes, so I can move it up and down, and I can move it left and right. So I have full control now of where that point is resting. And I just want to go back to 0, 0 for this. So that gives me my first point. And if I look at my box, it's looking for 2 points. So if I copy this whole assembly down, I have my second point. Now this point, maybe I want my box to be, 33 units wide by 37 units tall. Right? I connect that to point B and then point A, and then I should have a sliver of a box. Now the width is here. So now I can adjust this box to whatever I want on the fly. Okay? Now that whole assembly is needed to contain that box. So I'm going to right click and then I can group it, and now I can move this whole assembly as one component assembly. So now we want to get into things we can do with the box. So what sort of things do we typically do in drawing operations? We have move, we have rotate, we have scale, we have mirror, and we have an array. Copy is something that is inherent to the way the scripts are working, so a copy function does not exist. You're going to see why as we get through this. So when I want to move something in the scripting environment, the first part is, well, I want to move it. I should find the component for move. So I double click and I say, well, I need move. And I look, okay, well, I found move. And if I right click it and go to the help file, what is it asking me for? It's asking for a base geometry. So I've already created a box. So I would obviously want to connect my box to that geometry. And you'll see that it moves. Right? And we know that we're operating on this one. I can see what piece I'm operating on because when I select it, it highlights green by default in the viewport. If I don't want to see that original box, and this is where I'm talking about the copy, every time I move one geometry from an output to a new geometry on an input, it ends up just making a copy of it. So how we handle that is we just disable the viewing of that object, and I have now my new box moved. Now, I don't have any way to control the motion of this box, so I'm going to say, well, what is it looking for? And it's looking for a translation vector. So we know that a vector in a raster program, right, one handles pixels, the other one handles line data. In Grasshopper, the word vector is even beyond the scope of a line. it's determining magnitude, which is the distance, and direction at the same time. So it kind of goes back to physics when we did physics, or your structures. A vector in that sense has a direction and magnitude, right? So we need to define that direction and magnitude. Magnitude is going to be obviously a numerical input, so I can just copy one of these sliders over. And I only copy it because I hate having to set it every time. And if I connect that to my motion, it automatically throws a red flag. That red flag means that there's an error, and it says data conversion failed from number to vector. So a number is not a vector, right? It's not a line. A number is not a line. I need to define the line. Fortunately for us, a lot of those are already preset in Grasshopper. So I can go to the vector panel, or ribbon for that matter, and all the way at the end is a vector panel. And I can see I have a vector that goes in the unit X, the unit Z, and the unit Y. And then I also have this vector X, Y, Z, so I can define where my vector is going. So we'll do all four of those. So I'm just going to copy one down. And if I want to access these really quickly, I can just double click and click Y. It'll give me my unit Y. If I double click, I can do Z. Now if I plug in my unit X, it'll go and say, yeah, I'm okay again. It highlights gray. There's no errors. However, we don't have a magnitude to our vector. So the last part is to connect our number slider into the unit X. So now I can move my geometry along that X axis. If I wanted to go into the Y axis, I would connect my Y with direction and magnitude, and now I can move in the Y direction. Vice versa for the Z axis as well, and Z. Now that's fine. It's got an orthogonal movement, but what happens when I want to move it to a point that's not orthogonal? It's way out in space somewhere. And that's when we use the actual XYZ vector. So I click on that component, and it's looking for an X component, a Y component, and a Z component. And if I go to the help file, it says vector X component, vector Y component, vector Z component, and it's going to do a vector construct. So there's two ways we can approach this. This way may work or it may not work. I can also just draw a line between 2 points, and that serves as my vector. So we'll just copy these three number sliders for our X and Y components. And if I connect, I don't get an error. And I should, if I want to see what's outputting, I can always just type panel. And panel is just going to be a text output of what that's giving me. And it's giving me a directional point. Right, so that vector by default is going to come from 0, 0 to that point. And then I can connect that directly into my motion panel, and it'll take my piece and move it. So now, using that, I can move up and down, left and right, and side to side, anywhere I want in space. Okay? So I'll group those together here. And then these are my orthogonal movements, and I'll group them there. And that's my move command. So now what would be the next thing we would do, right? We would want to rotate this object, correct? Right, so I can double click and I should be able to rotate my object. And again, it's looking for a base geometry. Right? And when I connect one output of geometry to a new input of geometry, it automatically makes a new copy of it. So I would turn off the old move, and now I have my rotate. So now it's asking me for an angle. I'll right click and see what it's asking me for. It's asking me for a rotation angle in radians, and then also a rotation plane. Right, so that rotation plane is going to define one, where it's pulling from, so how it's going to rotate, what point it's going to rotate from, and also about what axis it's going to rotate on. So we'll get to that last. The first part we need to handle is this angle in radians. So here, who remembers what a radian is? How do we define what a radian is? Go ahead. It's another unit of measurement for angles. That is correct, obviously. Degrees to radians. So radians are measured in terms of pi. So the formula is I take pi over 180, and I times that by my degree, and that gives me radians. All right? So I want to be able to construct that. So I can also do mathematical operations with Grasshopper. So the first part is I need to set up the divisor, which is pi over 180. So I type in the word divide, which gives me divide curve, which I don't want. And I have division here. So then I look and see what that's asking me for. And it's asking me for an item to divide with another item. So it's generic data, which means it's just text. Now, what I can do is, under the math ribbon, under the utilities tab is pi. So I just click on it and I put it into A. So it's always going to be A over B. So whatever I want to divide, if I was going to do 1/4 of something, I would type in 1 for my A and then 4 for my B. So for my B, if I want to just do a simple text input, I'm going to make one of those panels that I made before by typing panel. And I'm going to double click in it, and I can also write into my panel, call it 180. Text could not be evaluated as an expression. That's not right. Okay, in that case, when it did work last class, when that doesn't work, what I can also do is under that parameters tab, I can just go ahead and define a number. Right click on it, I can set that number to be 180 and commit. Then when I connect it, I should get gray. Right, and if I want to know what that number is at any time, I can just do panel, or I can type panel here and then do it the long way and type in 180. Set to be a number, and there. And chances are the reason why it didn't work is because I hit the space bar after I did 180, so it doesn't read that as a number. All right, so that sets up my relationship for pi over 180. Now I need to multiply my degrees. So you can kind of see I'm always working backwards through what I need to do, which is hard for some people to grab onto, because you kind of got to know where you're going first and then work backwards when you're scripting. So the next piece would be setting up my multiplication. So I see my multiplication here. And my division is going to be whatever number I decide times whatever B is. Right? So B was my radian conversion. And then A is going to be my degrees, essentially. So I'm going to type in number to get number slider here. And if I right-click and edit that, I'm going to see that I can do real numbers or I can do integers. In this case, I want real numbers. So in my maximum, I can't go over 360 degrees. I would just be doubling on myself. So I would do 360 degrees. And I click OK. So that gives me my degrees, and I connect that to A. And then if I... so that gives me degrees to radians. So if I want to rotate by 90 degrees, I set my number slider to be 90 degrees, and I'm going to connect my multiplication result to my angle. Okay? Now, I don't see anything happen until I move it, because a square is a square is a square. But now you can see that I'm rotating. And by default, I'm always rotating by the 0, 0, 0 axis. Anytime it's asking for a plane or a vector, it's always going to default to 0, 0. You need to explicitly tell it where I want to rotate from. So if I wanted to rotate from the center of this box, so I just want to rotate the object based on its center, right? I would tell it to find the center point of that box. Or I can go back, and just like we had unit X, unit Y, and unit Z, those are vectors, I also have planar elements. So when we set a C-plane in Rhino, we have an XY plane, we have a YZ plane, and we have an XZ plane. So I would double click in the search and do XZ for my XZ plane, and then do XY for my XY plane, and then YZ for my YZ plane. Right? And I can connect each one of those and rotate. So right now I'm rotating about a different axis now. If I connect the XY plane, that's my standard rotate. And then my XZ plane, I'm rotating about the XZ plane. Now, if I want to rotate based on the center point of this box, first I need to find the center point of my box, right? So I would take this piece of geometry, because if I try and find the center point of the original box, it's just going to rotate based on that center point. In this case, I need to kind of do what we call a data recursion. So I'm gonna take the box and essentially find the center point of where this box is, which would be here under the move, and then plug that in to my planar element. So I got to go back to the old one to get to the new one. And how I do that is under Surface Tools. Uh-oh. Okay, so I'm going to go back to this other one. So under the Surface Tools and under the Analysis, so I can always analyze whatever I have to pull new pieces out of it. And I can do my box properties. So I want to get the properties of this box. So I connect my geometry into that. And then my output options are center, diagonal, area, volume, or degeneracy, which is a little more advanced than we need right now. And then I say my center is my plane. So I can see when I type in point to set my point for that, because I can't really see I can't ever preview an output until I connect it to another input. But that's my center point there. You can kind of see it highlight in green, hopefully. Now when I rotate, I should be rotating about the center point of that box. Okay? So we'll keep that there. Keep that there. So we'll group these together. I'll group these together. And I'll group these together. So those all go together there. Okay. So that handles my rotate function. So now, what if I wanted to mirror an object? So I want two of them mirrored. Same thing as the rotate option. If I double click, type in mirror, it's basically asking me for the same exact stuff, only it's not asking for an angle. It's just asking for the planar element of it. So I would connect this geometry in. And I see by default it's always going to go to the positive direction. In this case, it's always going to go to the y-axis. If I want to rotate based on its center point, I would just connect it by center point. And it's going to do that. Or I can define new planes to rotate on, or mirror on. So you'll see that I can mirror axis here, or I can go on the other plane of axis, and it runs it that way. And now what's nice is I can rotate each one together. Now let's say I want to have it a weird mirror axis, so it's not necessary or orthogonal, just kind of like we did our moving operation. I can just simply now copy this whole grouping of objects and then paste it, so I have a new segment of it. And then I can use that unit vector to define a new plane of mirroring, right? So now I can adjust where I'm mirroring that piece on. Is that not working? And actually, I am incorrect. So this is a case where we actually cannot use the vector as a rotation plane. So now we need to define a line, kind of our mirror axis. So if I was going to do the mirror command in Rhino, it's going to ask me for a mirror axis. So now I need to manually do that. So to draw a line, we know that we drew a box with 2 points. If I was going to draw a line, I just select my two original points, Control C and Control V. And then I connect a line between those 2 points. So I type in line, and the second one up is a line with 2 points, start point and end point. And I can see that line there. I can move it so you can see it. Right? And then I tell it that that's my rotation plane. And you'll see now I can mirror this based on any plane I want. That's a little one-off. I rarely use the mirror command unless I have a specific need for it. But I'm going to cover it anyway because it has some good concepts to go over. So I'm going to group that together. And I'm just going to disable that because that's kind of like a one-off. I just do it at this segment because it's the same as the rotate. So now I want to, let's say I want to array this box set. So I'm going to make a column grid out of it, right? The new version of Grasshopper actually has an array function to it. But before, we never had an array. So I have a linear array, a curve array, a polar array, a rectangular array, and a box array. And I think it's good to go over all of these because they're all pretty much the same. If I do a linear array, I have my geometry, my direction, and my count. So I'm going to take my original rotate command and take the output of that geometry. And because I don't want to keep going back and forth along this, I'm going to store this into a new geometry container. So I just type geo and then I have geometry. So just like I set a number or a point, I can right click and set one geometry that already exists in Rhino that I want to work on, or I can just take my old rotate geometry and connect it right here. And I can disable that rotate command now too. So now I'm going to work with just this geometry in this view. And the only reason why I do this is so it's easier on me to, it's a little easier on me to just manage in the workspace, because I don't want to keep going in and out over to other things. You get lost really quickly when you do that. So I'll just connect that geometry into my linear array, and it'll default you with whatever value it decides. In our case, we want to indicate a direction, which our direction now can be used through a vector, so I can definitely copy this over, because direction and magnitude is really everything for this operation. So there's my direction, right? And I can say I want to go left, right, up, and down. Hold on 1 second. All right, and then I have a count, right? So if I want a count of objects, I can Control C and Control V on a number slider, and I tell it how many I want. So maybe I only want 1 or 2. Now you'll see if I go negative, you can't have a negative count of numbers. So I can just edit that value slider to say my minimum is always 0. Right? So that's my linear array. Now if I type array again, I have my rectangular array, which is similar to the linear array. I can connect that geometry. And then it's going to ask me for the X count and the Y count. That's an easy one. I just take this same number slider and I connect it to my X and I connect it to my Y. Now it's asking for a cell. And if I right click on the word cell, it's going to tell me what specifically it's looking for. And it's looking for a rectangle. So just like we made a line and just like we made the box, we now need to make a parametric rectangle to define our cellular grid. So what I can do is take my 2 original points that I made for the box, Control C and Control V, and instead of drawing a line, I'm going to type rectangle, and I should have a rectangle by 2 points, and I connect into point A and point B, and this will give me my length, width, and height. So I would always want to go to 0 for the rectangle. I don't want a twisted rectangle for this. It'll probably throw an error at you if you do. Set that to 0. Right, and then this should define my width and length. So if I go really high with it, you can see there's my rectangular grid array. And then I take that rectangle and connect it to the cell. And that gives me my array. Right, so now I can adjust the spacing of that. And what's cool now is because we set up the relationships the way we did, let's say I want to rotate all these objects now. I can go all the way back to the original rotate command, and I can rotate all of these boxes now at the same time. Or I can go back to my original box itself and control the height of them all at the same time. Okay, so that's my rectangular array. Group that. So now my box array works similar to the rectangular array, only in the sense that now it's 3-dimensional. It's gonna create a 3-dimensional massing of these objects. So if I go to my array command again, just type array, I can see box array. And box array is basically looking for the same exact things the rectangular array was looking for, only in this case, it's now adding the Z count. So I would add a 3rd point into this. So I'm gonna go Control Z and Control V to everything here. And I'm just going to delete off my rectangular array and replace that out with the box array. Delete my grouping. There. And connect my geometry into that piece. And then I need 1 extra point for my Z-axis. Or my Z count, excuse me. So here's my cellular array there, and then my number slider here, I made 1 more. So I'll have 7 by 7 by 7. Now this cell is saying set 1 box. So in this case, we made a rectangle, and basically they doubled up on themselves. So in this case, I would go back to my original box command, where I made my box here, Control C and Control V. And when I drag it all the way over here, right, it's still connected to the old one. So to disconnect anything, I just right click, and there's a disconnect command, and I can disconnect that constructor. There. And then I say I want a point A and point B for this new box. And I flip those. Point A, point B, and then that's my cell. Oops. 3D box array cell. Because it's 0. So now I can grow that. And they all still have the same functionality, rotating and whatever with them. Okay. So I'll group that together. Now my other one is my polar array. So if I type array, my polar array is looking for a geometry, a plane, a count, and an angle. So if I right click on my angle, it's saying 2.0 times pi. right? And I believe if I go to the help file, it's probably going to be my sweep angle in radians. So we've already developed the radians for this, so we can copy that. So we have everything we need already established. I'm going to take this and make it so it's not visible. And now I need to piece together my other components for this, right? Because I've pretty much gone through most of the main elements of this. I connect my geometry in. There's my rotation. My plane we'll get to last, right? Because remember when we defined a plane, I needed to do it based on the mirror command, right? The mirror command defined my new plane. Basically, it can be a point or it can be a line. In this case, I'm going to make it a point. So I'm going to start with this point. Control C and Control V. And that's my plane. So now if I move this, it's rotating about a different point. Z is not going to do anything for you. And then I want to copy my number slider because I want to change my count, which is here. So I can adjust my count. And then my angle. So angle is the fill angle. How much of the circle do I want to fill? Maybe I don't want the whole circle. Maybe I only want a portion of that circle. All right, so I go back to my angles, or my degrees to radians function. I copy all of that. I drag that down and connect my angle. So now it's only going to fill whatever I want it to fill. Let's group that. So the last one is going to be this curve array. So the curve array is kind of like arraying along a path curve. So if I wanted to make like a parametric staircase, a spiral staircase, right? So first I would check and see if there's a helix command in here at all. Or a spiral for that matter, which I don't see one, right? So this is when I need to actually break away a little bit from the parametric side of it and do some actual modeling in Rhino. So in Rhino, I want to have my helical staircase. Actually, let's check the curve menu and just make sure that we don't have these. Yeah, I just have those. None of those. Yeah, I definitely don't have a spiral per se. So what I'll do is in Rhino, I'm going to go ahead and type in helix. And my start axis is 0, 0, 0. And then my end of my axis is 0, 0, 12. And that defines my curve. So maybe I want my curve really high. So I'm going to do helix. And then V for vertical. And then 0, 0, 0 for my start axis. I'll draw it up as high as I want it. And then I want my number of turns to be, maybe 6. So it's a little less. So that's my curve. Now that's going to be my curve that gets input. But I need to establish a relationship between what's in Rhino and what's going into the component panel. So how I do that is I double click and I just type curve. And it establishes a container that I can now link to any existing geometry in the Rhinoceros environment. So if I right click on it and set one curve, it's going to ask me to go into the Rhino environment. I click on it. So now that hides, or that is shows as green, which means that this is now selectable. I can go ahead and hide my curve in Rhino. So now this is an actual curve in the Grasshopper environment. It's no longer part of Rhino. And I'm going to connect that into my curve area. And then I'm going to take my piece of geometry here. And before I do that, I'm going to disable my polar array. And I'm going to connect that geometry into my path curve. And you can see it begins to rotate about that axis. Now, it's not entirely accurate with what it does, and that's mostly because of how the helix is made and where that geometry sits originally when I do my rotation. Yeah, because you can see it begins to follow the normal of that curve. If anybody wants to explore this deeper, I can work with you on it. I'm just going to add a number slider to get my count. And then I can add more along that function. So it's a little crazy. We need control over that. So in the event that you have something that looks as if this does, right? There's ways we can get it to actually work correctly. Is we can use the orient command. So basically what this is doing is taking that curve and it's dividing the curve, and then it's placing objects at each division point. But you don't see that happening. So that's my curve array, right? I'm going to group that together. You know, if I wanted to set a different curve, right, I can disconnect that, hold down Control and go backwards. And I can just say that I want to set a new curve. And without, yeah, it's going to make me set it. Usually you can draw in the curve too. So that's that. I'm going to group it and disable that. So let's say I want to go a little farther and I want to have more control over this array function, right? I'm going to take my curve here, Control C and Control V, so I have it separate from this assembly. And then I'm going to type divide. So now I'm getting into how we're manipulating things that exist. So I'm going to divide this curve. And you can see now it goes along that curve and begins to divide out segments of that piece. And then it's asking me for a count. And then it's going to ask me and it's going to give me out points. So my count is going to be, I don't know, maybe 40 of them, since that's what it was there. We can go more or less. And then I can use my orient command. And the one I typically use is this. We'll try the one and then we'll do the other one. So my geometry is going to be my box. And I want to take my original box is what I wanted. Actually, I want to take let's take the rotated box, which is this one. So we'll just take this one. That's fine. Then I can control the rotation. There's my geometry. And then my source, right, if I type panel, and I look at how those points are organized, right, it's giving me a list of points. So it's going to take each one of these and assign the box to each one of those points, right? And this is going to be essential for where we're kind of going with this. This is a list. So this is a list of items. I can have multiple collections of lists existing in the same output. So there's my point. Those become my source targets. And then I get it actually rotating about those. Excuse me, source. Source is going to be the source point, initial plane. I want to pick my center point that I made before, which was here. That becomes my source. And then my target is each one of these points. So then it arrays my objects along those points. Now, you'll need to, there's ways we can begin to get the normals corrected so it's actually rotating correctly. That's a little more advanced. This is more just conceptual things, and we'll definitely get into how those things resolve themselves as the tutorials move on. This will get you started, though, to thinking about it. And again, I still have control over, my rotation of those objects and my height, width, and length. See if we can just quickly get that plane normal. So how do you think we would go about getting this to orient itself? So does everybody know what a normal is? What's a normal to a surface? It's perpendicular. So I need to establish that perpendicularity. So this is my basic orient. Right? I'm going to go ahead and copy this set of... actually, I'm going to leave the orient here. We'll just disable that, because we can use the same other stuff. If I do my orient command based on a direction, so I'm going to orient it by directionality, right? I can go ahead and say that first I need a point orient on the box itself, and then I need the direction coming from the normal of that curve. So that way the stairs actually twist along the spiral staircase, right? So the first thing is to operate on this curve. So I needed to establish the perpendicular set from this curve. So how would I do that? Right? Couldn't I just offset my curve and give it a distance that's arbitrary? Right? And then do the same division that I'm doing up here. So I take this, Control C and Control V. And then I have two sets of points, and I should be able to connect a line between each one of those points. Right? And then those become my vectors. Keep that off to the side. And then I need to do the same thing. So I'm preparing my box. If I just go ahead and, it's a different orient command. So if I go to orient direction, so now I'm doing a direction orient. I'm going to take my geometry, which is my box. And for this, I really want the original box because I'm not going to be doing any really rotating with it or anything. I can always go back to it, but I'm going to take the original box. So I'm just going to type box, and I'm going to connect my original one into that container. And then I need, if I look at this original box, right, which is here, I'm going to disable this one. This is my rotated box. Right, I really need to think about how I want to orient it, because what I'm going to do is essentially take this object and I'm going to align it with each one of these vectors, right? So I would need to define a line that goes along the length of my stair. And to do that, I can do a couple things. I can decompose this box into its corners, or I can just go to the original points that I made, which were up here, which is there to there. And actually, I'm probably going to have to deconstruct it. Or I make a new point based on these elements. So let's make a new point based on these original ones. So I'll Control C and Control V for the point. And it's still connected, right? So I'm going to disconnect each one of the X and Y and Z coordinates here. And then I know that I want the X value, so the largest X value is handled here. So that goes into my X coordinate. My Y coordinate, it's always 0, so I take the 0 here from the top point. And then my Z coordinate is whatever is generally 0 too. Okay? And then I need to make a line from 0, 0. So I can just set a point, or I can take the original XYZ point, which is here. I'm going to make a point container. I'm going to pull that down over to here so I have it. and there's my endpoint. So my line's going the wrong way, it looks like. So we connected X to X, Z, I think Y should go there. That's my point. But it's going in the wrong direction. It should be down over here, right? Ah, that's because I'm looking at this the wrong way. Duh. So Y is actually here. So let's do our Y. There. And then my X is 0. There. So now I have my point where I want it, and I have my line here. And you can see, you can kind of see that it's highlighted there. So now that gives me my vector for my box. So that's my point. Here's my vector that I want to orient it on. Now if I look at what this is looking for, it's looking for one, the base geometry, which is going to be that box. So now I can turn that off. And then my point A is going to be this original point of 0, 0. My direction is going to be that vector I made. And then my point B is going to be my original curve's division points. And then their direction should be this line. There we go. So now I have them rotating and orienting themselves to the normal of the curve. And I can still adjust the length, width, and height of them. So all that is grouped there. And that's my orient direction. And we have a spiral staircase. Now what I could do is, since I have this already defined, I could go and plug in different geometry into it, and it'll do what it wants to do with rotating and everything. But you just got to really know what you're kind of going for. Okay. Now knowing that, right, I can define different array patterns, different grid patterns. So kind of where we're going with this is, if I mean, there's multiple things I can do. I can analyze faces with pixel data and do Voronoi diagrams and all kinds of fun stuff with it. And it's really, really simple to do. And we'll probably explore a lot. So we have, what, like 5 or 6 classes left? So we should get pretty in-depth into Grasshopper. What I would like to do is, there's no explicit homework yet in Grasshopper, but I want to make sure everybody's at least going in and trying these things out and figuring them out. So I want, it's not explicit homework, but I want you to be comfortable up to this point. So you should be able to make a box. You should be able to define a curve. You should be able to divide the curve. You should be able to orient, array, move, all those things. Do your translations, okay? All this is going to come in handy as you go, right? Is there any questions?